Hello, for this video, we will discuss a new topic, refrigeration and liquefaction. For refrigeration, I'm sure na familiar na kayo kung ano yun. It implies the maintenance of a temperature below that of the surroundings. Lahat naman tayo, di ba, nakakita na ng ref and naka-experience na ng aircon. Yan. So other uses of refrigeration used in the treatment, transportation, and preservation of food and beverages, manufacture of ice, dehydration of gases, checkan ko na lahat. Lubricating oil purification, low temperature reaction, separation of volatile hydrocarbons, and also cryogenics. Since a low temperature process must be maintained, it's necessary to absorb heat continually at a low level. So it uses liquid with a low boiling point to absorb heat at a low temperature by absorption. But the liquid must return to its original liquid state so that it can again absorb heat at the low level. Cycle siya. Kaya, absorb muna, pero kailangan i-return yung liquid at its original state para mag-absorb ulit at a low level temperature. Thus, it completes a series of steps through which the fluid passes, and that is called the refrigeration cycle. And we have different types of refrigeration cycles. We have the Carnot refrigeration, the vapor refrigeration, and the air refrigeration cycle. Under vapor refrigeration cycle, we have the standard and the ordinary vapor compression cycle. The Carnot refrigeration cycle is the most efficient cycle that can operate between two constant temperature reservoirs. And like the Carnot engine, all processes are reversible in a Carnot refrigeration cycle. It's actually just the reverse of a Carnot engine cycle. So ito yung heat engine na diniscuss natin in the previous topic. Diba, ang nangyayari for a heat engine, it absorbs temperature from a high temperature, it absorbs heat from a high temperature reservoir, then it performs some network, then it dumps the heat na excess or waste heat into a low temperature reservoir. In the Carnot refrigeration cycle, instead of the heat engine, ang tawag na ay heat pump. What happens here is that the heat pump absorbs heat from a low temperature reservoir. So, kanina ito, note the difference sa ito, it absorbs from the low temperature reservoir. Itong heat engine, it absorbs from the high temperature reservoir. And then, since it absorbs heat from a low temperature reservoir, work should be applied to the heat pump. It requires a work, and then it dumps the heat to a high temperature reservoir. So yung heat engine is a work producing process, while the refrigeration or the heat pump is a work requiring device. The Carnot refrigeration cycle consists of two isothermal steps and two adiabatic and reversible steps. Tingnan natin, saan ba yun? Okay. So, two isothermal steps, ito yun. And two adiabatic and reversible steps, ito yun. We also have a coefficient of performance, COP. It's the usual measure of the effectiveness of a refrigerator. It's the heat absorbed or yung QC at heat absorbed at the low temperature reservoir from the low temperature reservoir over the work shaft or the work input dun sa heat pump. Okay, but the work S is QH minus QC. So, replacing that in the equation, nagiging ganito equation. We can also express the COP in terms of the absolute temperature. So, ito yung magiging equation natin. It gives the maximum possible value of COP for, so by the way, ito yung Carnot COP and it gives the maximum possible value of COP for any refrigerator operating between two temperatures, TH and TC. And the COP of a Carnot cycle is independent of the working fluid and we call it a refrigerant kapag sa Carnot refrigeration cycle. But it depends on the TH and TC, on the two operating temperatures. That's why you won't see any information about the working fluid dun sa formula, but only the temperatures of the hot and cold reservoirs. As mentioned, this is the cycle of the Carnot refrigeration. Let's start with the wet vapor. Okay, it enters the compressor, and then sa compressor, it's compressed through a adiabatic and reversible process. Kaya delta S is 0. And then, it becomes a saturated vapor. It undergoes an isothermal process wherein it dumps the heat, okay, to the hot temperature reservoir. It becomes a saturated liquid. Then it enters an expander where so by the way sa compressor may work input tayo. Sa expander merong work output. So ano siya, Q equal to 0 din dyan, adiabatic, tsaka reversible. Then it becomes a wet vapor and from there may papasok siya sa evaporator and may isothermal absorption ng QC from the cold temperature reservoir. Let's solve this sample problem in the next video.